Thousands of years ago, before the rise of modern science, before the hum of electricity or the turning of engines, someone built machines that should have been impossible. Deep beneath layers of time and dust, fragments of metal, stone, and glass whisper secrets of genius far beyond their age. These are not legends carved in myth, but real discoveries pulled from the earth by accident, each one rewriting what we thought we knew about our own beginnings. How could a world without industry craft computers, self-healing materials, and nanotechnology? Who were the minds that saw the future through the haze of ancient fire and bronze? Tonight, we journey into the impossible, tracing the fingerprints of forgotten brilliance across centuries. These are the stories of 5 ancient inventions that, by every law of history, should never have existed. History is often told as a straight line, a steady climb from primitive beginnings to modern enlightenment. We are taught that every invention is the product of gradual progress, one discovery leading neatly to the next. But beneath that tidy version of history lies another story, one filled with anomalies and whispers of impossible genius. Across deserts, oceans, and crumbling ruins, archaeologists have uncovered objects so advanced that they defy the timeline we have built for ourselves. Machines with gears cut to microscopic precision, materials stronger and smarter than anything produced for centuries afterward, and technologies that suggest an understanding of nature far ahead of their time. These artifacts challenge our most basic assumption, that progress only moves forward. They hint at civilizations that reached extraordinary heights of science and engineering, only to vanish, leaving behind fragments that refuse to be explained. Were these sparks of accidental brilliance, or echoes of knowledge lost through war, disaster, and the erosion of memory? As we step through the corridors of time, we will uncover 5 of the most baffling creations the ancient world ever produced. We will explore how they were discovered, what they meant to their makers, and why they continue to puzzle scientists and historians to this day. Each one carries a story of human ambition, curiosity, and mystery. From the mechanical minds of ancient Greece to the master forgers of lost empires, this is not just a journey through invention, but through the human desire to understand and control the universe. These ancient devices are not myths or miracles. They are evidence that brilliance has visited humanity many times before, only to be buried again and again beneath the dust of forgotten ages. And perhaps, as we study these impossibilities, we will begin to see that the line of progress we draw through history is not straight at all. It bends, it breaks, and sometimes, it loops back upon itself, reminding us that the future has always been hidden in the past. The Antikythera Mechanism, the world's first computer. In the spring of 1901, a group of sponge divers braved the waters off the coast of Antikythera, a small Greek island wedged between Crete and Kythera. What they found beneath the surface was not treasure in the usual sense, but the shattered remains of an ancient shipwreck. Among the statues, amphorae, and scattered relics lay a corroded lump of bronze and wood. It looked unremarkable, a forgotten mass eroded by time. Yet within that rusted fragment slept one of the greatest mysteries in the history of science. When archaeologists first examined the object, they dismissed it as a piece of decorative machinery. But decades later, as technology advanced, X-ray imaging revealed something extraordinary hidden inside, a network of gears, dials, and inscriptions crafted with breathtaking precision. Slowly, the world began to realize what they were looking at, a machine from over 2,000 years ago that could predict celestial movements, solar and lunar eclipses, and even the timing of the ancient Olympic Games. It was an ancient analog computer, a device that should not have existed until the Renaissance. The Antikythera Mechanism was not the product of luck. It was the outcome of genius. Over 30 bronze gears meshed together in exact ratios, driven by a hand crank that turned the heavens into motion. The craftsmanship was so intricate that it would not be matched again until clockmakers began building astronomical devices more than a millennium later. It used mathematics, astronomy, and engineering so advanced that it seemed to leap centuries ahead of its time. To imagine such precision in the first century before the Common Era is to reimagine what the ancient world was truly capable of. The Greeks, often remembered for philosophy and art, also possessed minds that saw the universe as a vast machine, one that could be measured, modeled, and predicted. The Antikythera Mechanism is proof that they were not just observers of the cosmos but engineers of its mysteries. Scientists today still debate who built it. Some point to the workshops of Rhodes, where astronomer Hipparchus mapped the stars with near-modern accuracy. Others whisper the name of Archimedes, whose lost inventions once included mechanical spheres that simulated planetary motion. Whoever its creator was, they harnessed mathematics and metal with a mastery that seems almost alien in its perfection. As we peer into the reconstructed gears today, we are reminded that history's timeline is fragile. The knowledge that built the mechanism vanished after the fall of Greece and Rome, buried for over 1,000 years before humanity learned again how to build machines of comparable complexity. What other wonders may have disappeared with it, we may never know. The Antikythera Mechanism stands as both a triumph and a tragedy. A triumph of human intellect, and a tragedy of forgotten progress. It tells us that the ancient world was far closer to our own than we dare to admit. When we look at its interlocking gears, still turning silently in museum light, we are staring into the mind of someone who saw time itself as a machine, and built it with their hands. Roman concrete, the secret that outlasted empires across the ruins of Rome. Structures built more than 2,000 years ago still rise against the sky. The Colosseum, the Pantheon, the aqueducts that once carried water across vast distances, all stand as monuments to a civilization that refused to fade. Their survival is not luck or mere endurance. It is chemistry, a secret that the Romans mastered long before the modern world understood it. For centuries, engineers and scientists have tried to replicate the strength of Roman concrete, but only in recent years have we begun to uncover why it has lasted so long. Unlike the brittle mixtures of modern construction, Roman concrete was alive in its own way. Made from volcanic ash, lime, seawater, and stone, it contained tiny white inclusions of quicklime that gave it the ability to heal itself. When cracks formed, water seeped in and triggered a chemical reaction, reactivating the lime and sealing the damage naturally. It was a material designed not to resist time, but to adapt to it. Imagine the Pantheon, its massive dome unreinforced by steel, still standing after nearly 2 millennia. Beneath its ancient arches lies the evidence of an empire's quiet genius. Roman engineers didn't think of concrete as disposable. They saw it as an eternal bond between nature and man, forged through observation and experimentation. While modern concrete crumbles in a century, their formula endures storms, earthquakes, and the rise and fall of countless generations. The brilliance of Roman concrete was forgotten with the collapse of the empire. For more than 1,000 years, humanity built with weaker materials, never understanding why Rome's monuments remained unbroken. It wasn't until the 21st century that scientists, studying ruins under microscopes, rediscovered the secret hidden in those chalky inclusions. It turned out that the Romans' occasional imperfections were not mistakes at all. They were deliberate. This discovery forces us to reconsider how ancient builders viewed their craft. They were not bound by blueprints or computers, yet they experimented with chemical reactions in ways that foreshadowed modern materials science. They built for permanence in a world of impermanence, with the confidence that their work would outlive them. In an age when our cities crumble under the weight of time, Roman concrete stands as a quiet rebuke. It tells us that progress is not only about innovation, but also about wisdom. The ancients knew that the strongest creations are those that work with nature, not against it. Every weathered column and arch still standing today is a message from the past, written not in words but in stone. A message that reminds us that true mastery is not in building quickly, but in building to last forever. The Baghdad Battery, electricity before its time in 1938. A German archaeologist named Wilhelm Koenig was cataloging artifacts in the National Museum of Iraq when he stumbled upon something curious. It was a small clay jar, sealed with asphalt, containing a copper cylinder and an iron rod. At first glance, it looked ordinary, perhaps a simple storage vessel. But when Koenig examined it more closely, he realized he might be holding something that had no place in the ancient world. This object, later called the Baghdad Battery, dates back nearly 2,000 years, possibly to the Parthian or Sasanian periods. When replicas of the jar were filled with vinegar or grape juice, they produced a faint electric charge, enough to power a small chemical reaction. It was, by all appearances, a primitive battery. A device capable of generating electricity long before anyone knew what electricity was. The discovery left historians baffled. How could an ancient civilization, without any recorded knowledge of electrical science, create something that mirrored the design of a modern galvanic cell? The implications were staggering. Some speculated that these ancient peoples used the jars for electroplating gold onto silver, an art that required low-voltage current. Others believed the electricity might have been used for medical therapy, or even for ritualistic purposes, where sparks or tingling sensations could have been seen as divine. Skeptics argued that it might simply have been a storage jar for scrolls or papyrus, its metallic parts coincidental. Yet as more examples of the same design were unearthed, the pattern became difficult to ignore. The craftsmanship of the copper cylinders, the careful sealing with bitumen, and the deliberate placement of the iron rods suggested intentional engineering. Even if the Baghdad Battery was born from experimentation rather than understanding, it reveals something profound about the ancient world. Human curiosity has always reached beyond the visible, seeking to harness forces that could not yet be named. To the people who made these devices, the reaction between metal, acid, and clay might have felt like capturing a spark of life itself. Modern tests have confirmed that the Baghdad Battery can indeed produce around 1 volt of electricity. Not enough to power a lamp or a machine, but enough to change how we see the ancient world. It tells us that discovery often begins not with knowledge, but with wonder. Someone, somewhere in Mesopotamia, saw metals react in a way that defied expectation and decided to explore it. That act alone connects them to us more than 2,000 years later. Whether it was used for art, healing, or faith, the Baghdad Battery stands as a reminder that innovation does not always follow understanding. Sometimes it begins with the simple human impulse to experiment, to test, to see what happens when curiosity meets the unknown. In that way, the ancient inventors who crafted these strange vessels were scientists in spirit, touching the edge of an invisible power that would not be understood again until the modern age. The Damascus Steel, metal forged from mystery across centuries, tales were told of blades so sharp they could split a strand of silk drifting through the air. Swords that could cleave through iron, yet remain unbroken in battle. These were not legends, but the famed weapons forged from Damascus steel, a metal so mysterious and resilient that its secret vanished into time. The origins of Damascus steel reach back to ancient India, where a type of crucible steel known as woods was first made. Traders carried its ingots across Persia to the workshops of Syria, where master blacksmiths transformed them into blades that gleamed with a pattern like flowing water. To their owners, these swords were more than weapons. They were works of art, symbols of mastery, and emblems of civilizations that understood metallurgy at a level far ahead of their age. What made Damascus steel so extraordinary was not only its sharpness, but its internal structure. When modern scientists analyzed surviving blades under electron microscopes, they found something astonishing. Inside the ancient metal were formations resembling carbon nanotubes, microscopic structures that modern engineers use today to strengthen advanced materials. Somehow, without knowing it, blacksmiths over 1,000 years ago had manipulated carbon at a molecular level. How did they do it? The process is still not fully understood. The creation of Damascus steel required precise control of temperature, timing, and chemistry. The iron had to be smelted with plant materials that introduced carbon, then cooled and reheated in exact cycles to produce the perfect crystalline balance. Even the impurities in the ore, once thought to be flaws, may have played a role in creating its distinctive strength and sheen. It was craftsmanship guided by generations of experience rather than scientific theory, a delicate dance between fire, metal, and human intuition. The art of making true Damascus steel began to disappear around the 17th century. As trade routes shifted and the sources of wood steel dwindled, the knowledge faded. When blacksmiths could no longer obtain the right materials, the secret recipe was lost forever. What remains today are the blades themselves, silent relics of a forgotten craft, their surfaces still marked with the rippling patterns that once inspired awe and fear alike. Modern metallurgists have tried to recreate the process, and some have come close, but none have perfectly matched the microscopic structures found in the originals. The Damascus blade remains, even now, a symbol of human brilliance balanced on the edge of mystery. In the glow of the forge, those ancient smiths were alchemists, turning raw earth into a weapon that seemed alive with energy. They worked not from books or equations, but from inherited wisdom passed through generations of practice. Every hammer strike was guided by instinct born from centuries of tradition. The story of Damascus Steel is not just about metal. It is about knowledge that burns brightly for a time, then fades, leaving only echoes for future generations to rediscover. It reminds us that even the greatest achievements can vanish when their keepers are lost. The shimmering waves on the blade are more than decoration. They are the fingerprints of forgotten genius, a testament to what humanity once knew and what it must strive to learn again. The Lycurgus cup, nanotechnology in the Roman Empire. In a quiet room of the British Museum rests a goblet unlike any other. At first glance, the Lycurgus cup appears to be a beautiful piece of Roman glasswork, a cage-like chalice depicting the myth of King Lycurgus entangled by vines. But when light passes through it, something astonishing happens. In normal daylight, the cup glows a deep jade green. When illuminated from behind, it transforms, glowing a vivid, translucent red. The shift feels almost supernatural, as if the glass itself were alive. For centuries, this phenomenon was a mystery. Art historians admired it as a masterpiece of craftsmanship, unaware that it contained one of the earliest examples of nanotechnology on Earth. Modern scientific analysis finally revealed the secret. The glass contains microscopic particles of gold and silver, ground to a size so small they measure less than 1/1000th the width of a human hair. When light strikes the surface, these nanoparticles scatter and absorb wavelengths in ways that create the striking color change. In other words, the Roman artisans who crafted the Lycurgus cup had, through trial and error, mastered the manipulation of matter on a molecular scale. They achieved effects that modern scientists would not rediscover until the late 20th century. The cup, made around the 4th century, is both art and experiment, beauty fused with physics. The precision needed to create this effect is staggering. The gold and silver had to be evenly distributed throughout the molten glass, an almost impossible task without modern tools. How they accomplished this remains unknown. Some believe the effect was a fortunate accident, a byproduct of refining precious metals into the glass mixture. Others argue that it was intentional, that Roman craftsmen noticed how trace metals changed the color and luminescence of glass, and learned to control it through experience. Whatever the truth, the result is mesmerizing. The cup tells a story of myth and punishment, but its material tells a deeper story of human perception, of the desire to capture and shape light itself. When one looks upon the Lycurgus cup, one is seeing not just art, but the early marriage of science and creativity, centuries before those words were ever separated. It stands as a reminder that innovation often arises from the pursuit of beauty. The artisans of Rome may not have known what nanoparticles were, but they understood how to evoke wonder. Their creation still challenges us to see how art and technology are bound together, each pushing the other toward discovery. The Lycurgus cup has survived nearly 1600 years, its colors unchanged, its mystery intact. In its glow, we see a reflection of humanity's endless curiosity, our instinct to explore the unseen forces that shape the world. The Romans who crafted it could never have imagined the language we would later use to describe their work, yet they understood its essence. To master light is to master perception, and in doing so, they reached across time to touch the modern mind. This shimmering vessel, born of fire and imagination, reminds us that sometimes the greatest discoveries are hidden not in laboratories, but in art, waiting patiently for the light to reveal their truth. Lost knowledge and the fragility of progress. Every one of these ancient inventions tells a similar story. A moment of brilliance, followed by silence. A leap forward, then a fall into forgetting. Humanity has always been capable of extraordinary creation, but history reminds us that knowledge is fragile, as fleeting as the empires that guard it. When the Antikythera Mechanism sank beneath the Aegean, it took with it centuries of scientific understanding that would not resurface until long after the Renaissance. When the Roman Empire crumbled, its formula for eternal concrete disappeared into ruin, leaving future builders to start again from stone and clay. The art of Damascus steel, the chemistry of self-healing mortar, the gleam of nanoscopic glass, all vanished in the chaos of war, conquest, and time. Each discovery, no matter how advanced, was only as strong as the civilization that carried it. It is easy to imagine that human progress is inevitable, that we will always climb higher, understand more, and forget less. Yet the ruins of the past tell a different story. Knowledge does not march forward on its own. It must be protected, shared, and nurtured. When libraries burn, when artisans die without apprentices, when records are lost to conquest or pride, entire worlds of understanding vanish with them. Consider what it must have felt like to live at the height of these civilizations. To stand in the glow of a city powered by aqueducts and arches, to wield a sword that cut like magic, or to watch the stars through a machine that mirrored the heavens. To believe, as those people did, that their achievements would last forever. Then, in the span of a few generations, the light of that knowledge flickered out. What is lost is not just technique or invention, but memory itself, the bridge that connects one age of discovery to the next. When that bridge collapses, humanity must rebuild it from fragments, piecing together the past like archaeologists, fitting shards of pottery back into form. Each rediscovery becomes both revelation and lament, proof of what we once knew, and of how easily we can forget. Our modern world, built on servers and satellites, feels immune to such loss. Yet the ancients may have felt the same about their own monuments. The Pantheon, the libraries of Alexandria, the workshops of Damascus, all once seemed eternal. Their survival depended not on stone or steel, but on the fragile chain of memory that carried their knowledge forward. The lesson of these forgotten inventions is both humbling and haunting. Genius is not rare, but continuity is. Progress depends not only on brilliance, but on preservation. The ancients reached heights we can barely comprehend, then vanished into history's shadows, leaving behind whispers of what was possible. Each of these creations, the gears of Greece, the stone of Rome, the metals of Persia, are fragments of a greater truth. They remind us that human potential is timeless, but human memory is not. Without vigilance, the light of knowledge can fade, leaving future generations to rediscover what their ancestors already knew. In their silence, these lost inventions speak to us still. They warn that civilization is only ever one collapse away from forgetting how to dream. Across continents and millennia, from the depths of forgotten seas to the sands of fallen empires, there runs a single invisible thread. It connects the mind that turned bronze into gears with the hand that shaped glass into light. It binds together the architects who mixed living stone with the smiths who folded fire into steel. That thread is human genius, timeless and unyielding, flickering through history like a pulse that never stops beating. When we look at these inventions, we are not staring into separate moments of brilliance, but into one continuous story of imagination. The Antikythera Mechanism, the Roman concrete, the Baghdad Battery, the Damascus blade, and the Lycurgus cup are not accidents scattered across history. They are milestones in a hidden pattern, proof that humanity's greatest ideas are born again and again, even after centuries of silence. Each artifact whispers the same message, that progress is not a straight line. It is a cycle of discovery, loss, and rediscovery. The ancients reached forward into the unknown just as we do now, their hands guided by the same curiosity, the same need to understand the world. The stars they mapped are the same we study. The materials they forged are the same we manipulate with machines and mathematics. The difference lies only in what we remember. In the quiet glow of the Lycurgus cup, we see a reflection of our own world. In the gears of Antikythera, we see the beginning of every machine we have ever built. In the enduring strength of Roman concrete, we see our dream of permanence. These inventions are not the relics of primitive minds, but echoes of our own. They remind us that genius is not confined to any one age or culture. It is a language spoken across time, one that can be forgotten but never destroyed. And perhaps that is the greatest mystery of all. These wonders that should not have existed were not miracles, they were inevitabilities. The same patterns of thought, the same sparks of curiosity, emerge wherever humans seek to shape the world. Whether in ancient Greece or modern laboratories, the desire to create, to question, to reach beyond what is possible, is what makes us who we are. The unseen thread of human genius is not something buried in the past. It runs through us still, connecting every dreamer, inventor, and thinker who dares to look beyond the horizon. The ancients built machines of time and light. We build worlds of code and energy. Yet both are expressions of the same endless pursuit, the same hunger to touch eternity through understanding. As we stand in the present, surrounded by the marvels of our own making, it is worth remembering that we are not the first to hold the future in our hands. Others have done so before us, their work scattered in fragments across the earth. Their legacy is not in what they built, but in what they proved, that the human mind has always been capable of the impossible. The line of progress may bend and break, but the spirit that drives it never fades. It waits patiently, hidden beneath the ruins, until someone else rediscovers it and begins again. So what do these impossible creations tell us about who we are? They remind us that history is not a ladder, but a spiral, turning through ages of light and forgetting. Each generation believes it stands at the peak of progress, yet beneath our feet lie the echoes of others who once thought the same. Their machines have rusted, their secrets have faded, but their spirit remains within us. The ancients built wonders not because they possessed more knowledge than we do, but because they possessed the same curiosity, the same daring to ask questions no one could answer. They looked at the stars, the sea, the earth, and asked not what was known, but what was possible. That question is eternal. It is what drives us to explore, to invent, to push beyond the limits of our time. Perhaps the true miracle is not that these inventions existed, but that we found them again. That even after centuries of darkness, the evidence of their brilliance still waits for us in the silence of ruins and the dust of forgotten workshops. Each discovery is a reminder that knowledge never truly dies. It sleeps, waiting for another curious mind to awaken it. The Antikythera Mechanism, the self-healing stones of Rome, the electric jars of Baghdad, the lost blades of Damascus, and the shimmering glass of the Lycurgus cup are not just artifacts. They are messages written in metal, stone, and light, whispering across the centuries. They tell us that genius is not bound by time, and that humanity's greatest invention has always been its capacity to imagine the impossible. As we continue to build our own future, we must remember that progress is a fragile flame. It burns brightest when shared, studied, and protected. The moment we take it for granted, it fades. But as long as we remain curious, as long as we continue to wonder and to seek, that flame will never die. The ancients once looked toward the stars and built the impossible. Now, it is our turn.